The distributive property is something that's so useful in math, but unfortunately it's also so easy to get it wrong. We'll start off with some quick examples. Well, first of all, let's look at the algebra formula, right? It usually looks something like A times B plus C, and then what we say is that you then multiply the A. Let's use different color for that. We'll multiply the A times the B, and then we'll multiply the A times the C. And so as a result, you get something like A times B plus A times C. But there's so many cool variations on that, and I'm just going to walk you through a bunch and see what you think. So certainly let's try some negative numbers. Maybe we could do something like negative 3 times 2x minus 5. It's kind of a fun one. If you want, you can pause the video and try it yourself first and see if you get the same answer as me. I'm going to go ahead and say that this is negative 6x plus 15. Fun. Let's try another one. How about something like, what if we have something like just an x out in front, times maybe negative 7x plus 3. Again, if you want to pause the video and try it yourself, I'm going to go ahead and go for it in a second here. So this should turn out to be negative 7x squared plus 3x. Hopefully you agree with me there. And how about, what if we have whatever is coming after this? Does it make any difference? So we'll try something like negative 3x minus 5. And we'll multiply that times negative 2x, just for fun. Again, if you want to pause and try it yourself, that'd be great. Okay, here I go. I believe this is going to turn out to be 6x squared and then plus 10x. Hopefully you agree with me. And if not, if you find problems in these videos, please let me know. I'd like to get the fixes in. Okay. Now, maybe we'll try something a little bit more exciting. Let's throw some fractions in. We'll start with something not too terribly bad. Maybe, what if we have like 1/3 times, how about 6x minus 15? And again, if you want to try it first, that'd be great. Okay, so I believe this is going to turn out to be 2x plus 5. Hopefully you're okay with the fractions. Let's go ahead and take her up a notch, see what you think of this. How about this? There we go. See what you can do with that. Okay. Hopefully, this one's a little trickier. What we do is we divide the 20 by 5, that gets us 4, and then multiply by the 2. So that gets us 8x. That's something you should practice if you're not that good at it. Again, divide the 30 by 5, that gets us 6, then times 2, so that gets us 12, and then it'll be minus 12. Hopefully you're with me on that. I'm going to turn this around a little bit and see what you think of this one. We'll do some more fractions, but what if you have something along these lines? What if we have something like, and what else can we say? How about this? There, that'll be a fun one. Go ahead and pause the video, try it yourself, see what you get. Okay, well, here's what I get. Again, we're going to divide the 24 by 3. That gets us 8. Times 2, that gets us 16x. And then we're going to divide the 24 by 4. That gets us 6. And then times 3 is 18. So minus 18. So hopefully you're with me on those. If you are, great. That's kind of the basics of the distributive property. And let's take a look at another aspect of this, though. Here's a problem where there's a very common mistake that people make. They see x plus 3 squared, and they believe that that is the same as x squared plus 9. Now, this has nothing to do with the distributive property. So you might ask yourself, why am I mentioning it here? And the reason is because people mistakenly believe that they can distribute this 2 to the x into the 3. But the problem is this is not the distributive property. You'll notice the distributive property is when we have something times two things being added in parentheses, and then we multiply that something times each of the things that's being added. Well, here we do have things that are being added in parentheses, but we're not multiplying something times either of those things. What we're really saying here, what we should be doing correctly, is just apply the exponent in its literal definition. It means it's this times itself. This should really be, I'm going to go ahead and cross this off. This is wrong. What it should really be is just x plus 3 times x plus 3. Whatever that is, okay? And that certainly does not get us x squared plus 9. Another common mistake that people make is this. They think that they can do something like this. Try this. Again, the easy mistake to make here is, well, actually, before I say it, why don't you try it yourself and see if you make the mistake or not. Okay, now I'm going to try to explain. Let's see if you did it correctly. A common mistake people make is they think that they can distribute, in here, and then they think they have to distribute one more. And that's not the correct application of the distributive property. So let's go ahead and get rid of that because that stuff's just wrong. Really, we do have the option of distributing here if we would like, but we can't also distribute over there. We'd get the wrong answer. And it's pretty easy to check. If we just threw all numbers in here, we could see very easily that one way works and one way does not. But what happens here, what's better to do in this case than trying to distribute, it would be much better if we simply use the commutative property. Move that 1/3 to the front, and then it's real quick and easy to see that 3 times 1/3 is just 1, and that simply gets us 1 times x plus 2, so that's just x plus 2. So I'd much rather have you do that when you see something like this. Don't even bother trying to distribute. And then likewise, here's another issue that I see coming up occasionally, is people are not entirely sure what to do maybe when they have something like this. Do I multiply the -3 times the 4 and the -3 times the x? And the answer is no, we do not. This simply turns out to be, well, what we really should do here is use the associative property. And the associative property says that if I have something times two things that are being multiplied together, if I have something multiplying other things that are being multiplied, I can just remove the parentheses. And I'll just remind you of that real quick. A times B times C should get us exactly the same as A times B times C. And in fact, we could even do, this. And that should get us the same result as well. That's called the associative property. So what we do here is we could just throw away the parentheses and just recognize, oh, it's just -3 times 4 times x. That gets us -12x. And by the way, I should have been more clear. This guy up here, we used the commutative property by moving the 1/3 closer to the 3. And again, that's something that'd be nice if you knew about, is that, the commutative property says, hey, if I have A times B times C, there's nothing wrong with making that into A times C times B. I should still get the same product. And that's essentially what I did. I just took this guy. This is something times something times something, and I just moved I switched these two guys. So now the 1/3 comes first, and then the x plus 2 comes second. That's called the commutative property.